Okay, Assalamualaikum and hi everyone. I would like to discuss our sp3d hybrid orbital. Alright, so here is the definition. So mixing s orbital with 3p orbital and 1d orbital, it will form 5 sp3d hybrid orbital. So there are 5 electron pairs and all 5 electron pairs are arranged according to trigonal bipyramidal shape. And there are two bond angle here. So this is 90 degree and 120 degree. Okay, so this is a diagram to show one s orbital mixed with 3p orbital and 1d orbital in order to form sp3d hybrid orbital that have 5 hybrid orbitals. Okay, so now I have 4 examples here. Alright, so take a look at the first example. Alright, so the first example is PF5. For first of all, we have to draw the Lewis structure. So here is the Lewis structure. Don't forget to calculate the total number of valence electron and then draw the molecular shape. But first we have to identify the class of compound. So when we refer back to the Lewis structure, there are 1, 2, 3, 4, 5 bonding pair electrons. So the class of molecule is AB5. Alright, so the shape here is trigonal bipyramidal. Alright, so there are two bond angle here. So this one is 90 degree and this is 120 degree. So here is how you can write the explanation. So you have to mention about the shape, that is trigonal, bipyramidal, and with the bond angle. Okay, now how to identify the type of hybridization. Refer back to the molecular shape. We have 1, 2, 3, 4, 5 sigma bond. So therefore there are 5 electron pair at the center atom. Okay, therefore the type of hybridization is sp3d. So all the 5 electron pairs are arranged according to trigonal bipyramidal shape. Okay, now we move to the orbital diagram, step number 4. Right, so for the orbital diagram, so first of all, you have to write the orbital diagram for the center phosphorus at the ground state. So we know that phosphorus has 5 valence electrons. So therefore at the ground state, there are 1 paired electron and 3 single unpaired electrons. Which means that at the ground state, phosphorus can only form 3 sigma bonds. However, when we refer back to the structure here, we want to form 5 sigma bonds. So therefore, one of the electron from 3s has to be promoted to 3d. Okay, notice here, even though the 3d orbital is empty at the ground state, however, you have to draw it. Why? In order to explain, one electron from 3s is promoted to 3d. So you can write the explanation like this. So you have to mention phosphorus can form 3 sigma bond and one electron has to be promoted from 3s to 3d. So next it will be form excited state, and the excited state there are 5 single unpaired electrons. Right. However, all this electron is unstable, so that's why we have to mix 1 3s orbital with 3 3p orbital and 1 3d orbital in order to form sp3d orbital that consists of 5 hybrid orbitals here. Okay. At the hybrid state, all the electron is single unpaired electron. However, there are 4 empty 3d orbital and we have to write it down. For the hybrid state, just label 3d empty orbital. So here is how you can write the explanation. Okay, how sp3d is formed. Alright, next we have to write the orbital diagram for the terminal. So terminal atom here is fluorine. So fluorine is located in group 17 and it has 7 valence electrons. So as we can see here, so the sigma bond is formed when 2p orbital of F overlap with sp3d hybrid orbital of P. Okay, here is the explanation that you can write here. Remember, have to mention overlapping 2p orbital of F with sp3 hybrid orbital of P to form sigma bond. Okay, now we move to the drawing. Okay, orbital overlapping. Right. You can use the molecular shape as the reference to draw the trigonal bipyramidal. So it's easier if you draw, okay, for the two orbital, hybrid orbital like this. So each hybrid orbital of phosphorus is overlapped with p orbital of fluorine. So for p orbital is lambda shape. Next, the overlapping areas, we have to show the electron, spin up, spin down, and then we have to label sigma, and then label the 2p orbital. Okay, and then the hybrid. Alright, so and lastly, okay, the atom, terminal atom, and also the center. So we have done for the first example. Now we move to the second example, that is SEF4. Alright, so first we have to draw the lead structure here. So here is the lead structure. So as we can see here, there are two electron valence here. So you have to place it on the center. Okay, next, draw the molecular shape. So first you have to identify the class. So refer back to the lead structure. There are 1, 2, 3, 4 bonding pair with one lone pair. So the class of molecule is AB4E. So the shape here is seesaw or distorted tetrahedron. So the bond angle here, we have two bond angle here. So this is less than 90. However, for this one is less than 120. Here is how that you can explain. So you have to explain the shape, seesaw, bond angle, less than 90 and less than 120. Alright, next, for the type of hybridization, refer back to the molecule. There are 1, 2, 3, 4 sigma bond plus 1 lone pair. Okay, so therefore there are 5 electron pair on the center atom. So therefore the type of hybridization is sp3d. On the 5 electron pair are arranged according to trigonal by pyramidal shape. Don't get confused here. So the shape for the sp3d is trigonal by pyramidal. So all the 5 electron pairs are arranged according to trigonal by pyramidal. As the for seesaw here or distorted tetrahedron, this is referred to the actual shape of SEF. Okay, now we move to the orbital diagram. So for the orbital diagram, we start with drawing the ground state, which refer to SE. So SE, we have 6 valence electron. Okay, when we refer to the ground state, they are 2 paired electrons with 2 single unpaired electrons, which means SE can only form 2 sigma bond. Okay, however, when we refer back to the molecular shape, so SAF4 form 4 sigma bond with one lone pair here. So one of the electron from 4p orbital has to be promoted to 4d. So that's why you have to draw the 4d orbital even though there is no electron in the 4d orbital. Okay, so here is the expansion. So mention about Se can form only 2 sigma and one electron is promoted from 4p to 4d. Right, so therefore it forms excited state. So at the excited state, we have one paired electron with 4 single electrons. So which means that the paired electron here is represent the lone pair electron. Okay, alright. Next, since the excited state is unstable, so we have to mix one 4s orbital with 3 4p orbital and 1 4d orbital. So here is the explanation that you can write. So it will form 5 sp3d hybrid orbital. Okay, so there are 1 paired electron with 4 single electron here. And you can see here we have 1, 2, 3, 4, 4d empty orbital. So you have to draw it down here and label 4d empty orbital. Okay, now we move to the orbital diagram for the terminal, which refer to fluorine. So fluorine, we have 7 valence electron. Okay, so we can see clearly here the overlapping of 2p, okay, 2p orbital of F with sp3d hybrid orbital. Okay, which refer to the single unpaired electron here, it will form sigma bond. So here is how that you can write the explanation. Overlapping 2p orbital of F with sp3d hybrid orbital of Se form sigma bond. Alright, so this is for the explanation for the 4 sp3 hybrid orbital. So now for one more hybrid orbital of sp3d. So you have to explain about its accommodate for the lone pair. So here is the sample of explanation. Alright, one sp3d hybrid orbital accommodate one lone pair electron of Se atom. Okay, now we want to draw the orbital overlap. So you can use the molecular shape as the reference, right? So the shape for sp3d is trigonal bipyramidal. So draw the sp3 hybrid orbital first. Okay, overlap with 2p orbital of F. Alright, so at the overlapping area, so you have to draw the electron, right, as well as the lone pair and label sigma. Okay, and then label the each of the orbital. This is 2p. Alright, so this is sp3d. And lastly, don't forget to label the atom, terminal atom, and as well as the center. Yeah, this is Se. Okay, so we have done for the second example. Now we move to the third example, which refer to ion. Right, so this is example for an ion. So first of all, we have to draw the Lewis structure here. So this is the Lewis structure. So please remember, after you have add the total number of valence electron, right? So since this is an ion, so since an ion have more electron, so therefore you have to add electron. How many is referring to the chart? Since here is -1, so you have to add 1. And then complete the rest. And we can see that we have 6 valence electron here. Place it on the center here. Okay, next, molecular shape. So first you have to identify the class of molecule. Refer back to the Lewis structure. We have 1, 2 bonding pair with 3 lone pair electrons. So the class of molecule is AB2, E3. Alright, so one more thing, don't forget, because this is ion, so you have to draw the square bracket and the charge. So for AB2E3, alright, the shape here is linear. And draw the actual molecular shape. Okay, so don't forget this square bracket and the charge. Right, so here is how you can write the explanation. Right, the bond angle here is 180. You have to mention about the shape that is linear. And the bond angle here is 180. Right, for the ion, whether cation or anion, so you have to add one more step here, and that's for the formal charge. Because we want to identify the negative charge is located on I atom or Cl atom. So we have to calculate. Right, so iodine we have 7 valence electron. Okay, minus. So we have here 1, 2, 3, 4, 5, 6, 7, 8. So 7 minus 8 equals to -1. So the negative charge is located on I atom. So for the chlorine, we want to make sure whether this is neutral or got charge. Chlorine has 7 valence electron, so minus. Okay, we have 1, 2, 3, 4, 5, 6, 7. So equals to 0. Okay, next we move to the type of hybridization. Refer back to the molecular shape. They are 1 sigma bond, 2 sigma bond, plus 1, 2, 3, 3 lone pair. So total up is 5 electron pair. So the type of hybridization here is sp3d. All the 5 electrons are arranged according to trigonal bipyramidal. Alright, next we move to the orbital diagram. Alright, so for the orbital diagram for the center atom, so you have to label I minus since I have negative charge. Right, so for the neutral I, it has 7 valence electron. However, we already calculate the form of charge. I is form I minus ion. So therefore, it has 8 electron. Alright, so as you can see here, at the ground state, I minus cannot form any sigma bond because there are 1, 2, 3, 4 paired electrons. However, according to the molecular shape, we want to form 1, 2 sigma bond. Okay, and then we have 1, 2, 3 lone pair here. So therefore, it needs 2 single unpaired electrons. Therefore, one of the electron from 5p has to be promoted to 5p here. Okay, one only. Okay, in order to form 2 single unpaired electrons. Okay, so you can write like this for the explanation. Okay, at the excited state, so there are 3 paired electron with 2 single electron. So the paired electron here is to represent the 3 lone pair electron. Okay, however, at the excited state is unstable. So we have to mix one s orbital with 3 5p orbital and one 5d orbital to form 5 sp3d hybrid orbital like this. Okay, so then you have to draw the electron, 3 paired electron and 2 single electron. You can see here that there are 4 5d empty orbital. You have to write it down here and label 5d empty orbital. Alright, now look at, we move to the terminal atom that is referring to the Cl. So Cl, we already calculate Cl is neutral, 0. So which means Cl has 7 valence electrons. Alright, so we can see here that the sigma bond is formed when 3p orbital of Cl is overlapped with sp3d hybrid orbital that is single unpaired electron. So this is a sample for the explanation. Okay, overlapping 3p orbital of Cl with sp3 hybrid orbital of I minus form sigma bond. Okay. Next, another 3, which means this one, paired electron here, 3 paired electron here. So here you have to explain, okay, hybrid orbital accommodate the 3 lone pair electron of I minus. Okay, so complete for the explanation. Now we move to the orbital overlap. So you can use the manipulation as the reference. Okay, you have to draw the sp3 hybrid orbital. The lone pair, you have to place it, okay, here, meaning that the bond angle 120 here. And then for the overlapping of 3p for Cl, and then label sigma. Alright, so next, don't forget to label. This is sp3d. And lastly, the terminal atom Cl. The center atom here is I. And because it exists in ion, so you have to draw the square bracket and the charge outside. Alright, so we have done for the third example. Alright, so we continue for the fourth example. Okay, so this is example for the cation. Right, so first you have to draw the Lewis structure. Okay. Right, so for the cation, after you have you have count the total number of valence electron. Right, so we have to minus the number of electron. So we know that the cation has less electron. So referring to the charge, so since it's positive 1, so it has less 1 electron, so minus 1 here. Okay, and then we can see here we have balance another 2 electrons. We just place it on the center atom. And because this is ion, so we have to draw the square bracket and the charge outside, positive charge. Next, for the molecular shape, we refer to the Lewis structure. So we have 1, 2, 3, 4 bond pair and 1 lone pair. So the class of molecule here is AB4E. Right, so the shape here is seesaw. Alright, so next you draw the molecular shape like this, and then have to draw the square bracket and the charge. So here is the sample of the explanation. Mention about the shape, seesaw, and the bond angle here. Okay, less than 90. So the less than 90 is referring to here. Less than 90. And the bond angle here is less than 120. For the ion, the cation or an ion, you have to add one more step, that is formal charge. So we have to calculate the formal charge in order to identify the position of the positive charge here, whether it's located on I atom or at the Cl atom. Okay, so we calculate. So iodine we have 7 electron. Okay, so look at the Lewis structure. Okay, for the bonding pair we just count it 1. So 1, 2, 3, 4, 5, 6. So meaning that 7 minus 6 is equals to positive 1. So the positive charge here is located on I atom. So now we want to identify whether the Cl atom is neutral or not. So 7 minus, okay, 1, 2, 3, 4, 5, 6, 7. So 7 minus 7 is equal to 0. So all the Cl atoms are neutrals. Okay, now we move to the type of hybridization. Take a look at the molecular shape. Right, so we have to refer the sigma bond as 1, 2, 3, 4 sigma bond with one lone pair. So total up here is 5 electron pair at the center atom. So therefore the type of hybridization is sp3d. And all the 5 electron pair are arranged according to trigonal by pyramidal shape. Alright, so now we move to the orbital diagram. So for the orbital diagram, start with the center. So since we already calculate the formal charge for the iodine is positive charge here, therefore the orbital diagram we have to label I plus. So in neutral, okay, so we know that iodine have 7 valence electron. However, iodine now become I plus, so meaning that less 1 electron. Okay, so therefore at the ground state, I plus has 6 valence, 6 electron. Alright, so at the ground state we can see here there are 2 paired electrons and we have 2 single electrons, which means it can form 2 sigma bonds. Okay, we refer back to the molecular shape. So we want to form 1, 2, 3, 4 sigma bond with one lone pair. So therefore, one of the electron from 5p has to be converted to 5p. And the paired electron in 5s is renamed to show the lone pair electron. Alright, so now this is the sample of explanation that you can write. So we can mention I plus ion can form only 2 sigma. Okay, and then one electron is converted from 5p to 5p in order to form excited state. Alright, so at the excited state, there are 1 paired electron to represent the lone pair, and the other 4 is single electron. However, the electron at the excited state is unstable, so we have to make one 5s orbital with 3 5p orbital and 1 5d orbital in order to form 5 sp3d hybrid orbital. Okay, like this. Okay, now we can see that there are 4 5d empty orbital. Then we have to write it down, okay, in the hybrid state and label 5d empty orbital. Right, for the terminal atom, it's referring to Cl. So Cl is neutral, so which means it has 7 valence electron. Alright, so from here we can see the sigma bond is formed when 3p hybrid orbital or Cl is overlapped with sp3d hybrid orbital that consists of single electron here. Okay, as for the paired electron in sp3 hybrid orbital, this one is to show the long. Right, so here is the example for the explanation. Right, so we can write here overlapping 3p orbital of Cl with sp3 hybrid orbital of I plus form sigma bond. And then one more hybrid orbital of sp3, so you have to mention one sp3 hybrid orbital accommodate one lone pair electron. Right, so now for the orbital overlap, so the shape for sp3 is trigonal bipyramidal. You can use the molecular shape here as the reference. Start with drawing the sp3 hybrid orbital. So next, one hybrid orbital or sp3 accommodate the lone pair. Just draw spin up, spin down. And then the other 4 is overlapped with sp3p orbital. Okay, and then you have to draw the electron spin inside, and you have to label sigma. Okay, don't forget to label all the orbitals here, sp3p. Okay, and then here is sp3d. Alright, so lastly, label this is Cl, and this is I. And since this is ion, so you have to draw square bracket as well as the charge, same like the molecular shape. Okay, so we have done all the 4 examples. So we have done